there are different types of risks, I think Swapnika has talked about all of these, but one acronym that I found useful is this thing called Pestle, which people use in several parts of the world. P stands for political risks. Okay, so all kinds of regulatory, governmental risks, all risks that can come through, changes in the view of a government organization towards the project. So it could be a change of government, sort of taking away the concession from a private player. It could be a change in regulation. It could be a very slow judicial system that doesn't allow you to seek redress effectively, all of that, right. So the E stands for economic, right. So these are all your market risks, right. So there is stagnation in the economy, there is a recession, people are not able to pay, you're not able to sort of make enough revenue, or for whatever reason there's a shortage in demand. All of those kinds of risks, economic, financial in some cases, fall under the E. Interest rates go up, etc. S is the social risks, people liking the project or not liking the project, protesting against the project. So that's another category of risks to look at. T stands for technical or technological. These are the engineering risks, right. So I'm building a flyover. What if it collapses? What if my foundations sink? What if, as I'm tunneling under the ground, parts of the road collapse? So all of these are technical challenges, technical risks that I have to mitigate. E are the environmental risks, right. So what am I doing to flora and fauna? Am I just destroying forests to create a road? What does that do? How does climate change play an impact? What do environmental action groups have to say about this? And L sometimes stands for legal risks, and legal risks are often separate from political risks, because legal risks are risks, changes of law, judiciary, all of that, where political risks relates more to elected representatives, political parties, and so on. So this is just another way of slicing and dicing risks. There are many ways, right. But to really bring the so I see all of these subsets which we've talked about, right. And so I think these are the two main categories, and I want to spend a minute on each. There is the decisioneering school of thought and the managerial school of thought. Essentially, we know we have risks, right. Any activity you have risks, right. Walking, right. What do you do about the risks? The two schools of thought, one is deal with it in terms of probabilities, okay, and that's so that school, looks at risks like this. Says you're building a toll road, right. There are risks. People may or may not use the road, right. So economic conditions may be such that a lot of people drive on the road, they may not, right. There are risks. So let's figure out probabilities, okay. One probability that I want to understand is, what is the state of the economy going to be going forward, right. So maybe there's a 25% probability that the state of the economy will be good, growing 10%. 45% probability that the state of the economy will be neither good nor bad, I mean sort of relatively slow but steady growth, right, 5%. But there's a 30% chance that my growth might dip to very low levels or might actually be negative, right. All of these have an influence on traffic, right. Presumably if the economy grows, there will be more jobs, more people commuting, traffic will increase, right. If the economy is poor, then perhaps there will be a reduction in traffic. But again, the relation between the state of the economy and the traffic need not necessarily be one-on-one, okay. So for instance, you might have, so maybe I'll show you this table in a second. Say if the economy is high, there's a 60% chance that traffic will also be very good, right, or the traffic will be high. If the economy is good, there's a 60% chance, but there is a 30% chance, right, that the traffic may not really increase very much, right, because there are many drivers, right. It's just because the economy is better, we are all not going to start using the road, right. Maybe the economy grows in a way that actually reduces the need for people to drive on the roads, right, because telecommunication functionality is available. Maybe the jobs that are created are essentially being created overseas. Maybe we are using our engineering skills to design structures or whatever abroad, and therefore although the economy is growing, we are getting more projects, our people are prospering and earning more money, doesn't necessarily mean more people are traveling on the road, right. So maybe they are actually traveling less because now they're sitting in front of a computer, Skyping or whatever. So there are various factors at play. So I have this table that says if the economy is good, there's a good chance that traffic will be high, and a small, but there is some chance that the traffic may not really be that high. On the other hand, if the economy is bad, there's a pretty large chance that the traffic might get affected, but a relatively low chance that despite the economy being bad, traffic will pick up because people are really looking for jobs, right? So they are actually going to travel further and further, right, to pick up jobs. So this is, somebody has done this analysis, right, based on data and come up with these probabilities, right? So you can probabilitize the situation, and then you sort of say, okay, this costs $1 million to build. If the traffic volumes are actually high, then I might make a revenue of 1.4 million, right? If the traffic volumes are medium, I make a revenue of 1.2. Traffic volumes are low, I only make $500,000, right, which would incur a loss. So then I can build these decision trees, right? So obviously I want to know, there's uncertainty here, there's risk, right? The only thing for sure is it's going to cost me $1 million to build the road, right? The rest of it depends on the state of the economy, the state of traffic, that will determine how much revenue I get, right? There's a lot of fuzziness involved, okay? So I can engineer this by looking at things like decision trees, right? So I can say, okay, if I make a decision to invest, okay, then there's a 25% probability that the economy will do good, 45% it will be okay, 30% that it will be bad. If the economy does well, right, there's a 60% chance that traffic will be high, 30% chance. So these are various states, right? The economy could be good and the traffic could be high. The economy could be good, the traffic could be medium, right? The economy could be bad, the traffic could be high, right? These are all states. Depending on each state, there's a revenue. Every time there's a high traffic, I'm going to make 1.4 million, right? Every time there's low traffic, I'm going to make $500,000. Okay, so each of these possible pathways, right, have a probability associated with them. Okay, so this particular pathway that I've just sort of marked here, there's a 25% chance that the economy will be good and a 60% chance that if the economy is good, traffic is also high, right, which means there is a 0.25 times 0.6 probability, right. So what is this? 0.15. So 15% probability that I will achieve this outcome. Similarly, each of these outcomes have a probability, right. So this had a 15% probability, there's a 7.5% probability. Each of these outcomes have a probability, right. So now I can actually find what we call an expected value, right, of the project by essentially multiplying the probability. There's a 15% chance I'll make 1.4 million. There's a 7.5% chance I'll make 1.2 million. There's a 2.5% chance I'll make 0.5 million, right, and so on. So I can just multiply all of these, right, and add that sum, right, and of course the total of these probabilities will be 1, right, because these are all the possible states of the universe as far as my road is concerned, right. So the total probabilities add to 1, okay, and yeah, so if I do not invest, on the other hand, right, you could think about it as I've essentially saved $1 million, right. So if I invest, right, I'm expecting a certain return. If I don't invest, I've sort of saved $1 million. So if you do the mathematics, we do the multiplication, which is what we talked about, the expected value of the investment comes out to 1.08 million. If I invest in the road, right, my expected outcome is 1.08 million, right. Now I will never get 1.08 million, right. I'll either get 1.4, 1.2 or 0.5, because the traffic will be high, medium, low. I'll get one of these three, right. But because there is probabilistically the expected average value of what I get is computationally 1.08 million against an investment of 1 million, right. So there is a marginal profitability associated with this investment, right. So here I've taken risks, I've put them into a probability tree, I've come up with an outcome, and now I have to make a decision on that outcome, right. If I have better projects to invest in, I might discard this project. If I have no other project to invest in, then I might give it some serious consideration, right. A risk neutral person would say, look, I invest 1 million, I get 1.08 million back, right. I'm making a profit, there are no other opportunities on the horizon, it makes sense for me to do this, alright. So a neutral person would say yes, alright. A risk prone person who's keen on taking 6 would also of course say yes, right. A risk averse person, right, might look at it and say, look, hang on, right, it's 1.08, that's not a whole lot greater than 1, right, it's about marginal, and there are enough chances that I might end up with the $500,000 outcome, right. So the profits here aren't high enough to justify to me the risk of taking the $500,000 outcome, right, and as a result of which I am not going to invest, right. So you arrive at a decision variable based on probabilistic analysis, and then you decide based on your risk perception what you want to do, right, a risk averse person, and so there are all these risk profiles that you can build. I'm sure there's some online tool where you can figure out what your risk profile is, right, and there are categories. There are other things you might also want to do, right, and this is where people in Indian PPPs might go in and say, I want some viability gap funding, right, this is barely viable, I'm not willing to take the risk, can you provide me with like 200,000 a grant, right, so that my overall profitability is likely to be closer to 1.2, and so now I come up with instruments, right, but these instruments are rooted in probability. Right, I have asked for 200,000 because I've ended up here with a calculation of 1.08. If I had ended up here with a calculation of 1.2, I might have asked for 50,000 or very little, right. So essentially what we are saying is put numbers, right, use numbers to assess these risks, right, and then try to sort of figure out financial means or other means to actually, or are there ways in which you can work with these numbers, right, are there ways in which I can change the probability, right, can I do something to improve the state of the economy, right, so essentially work with numbers. Well, it becomes the collective risk profile of the organization, right, so essentially you find some way of summing up. So these are all, obviously there's no science to it, right, you can take individual profiles, figure out some way of summing them up, etc., right, but this is the probabilistic approach. Sure, so this is a very simple way of looking at probability, there's no variation, right, so I can do, and we'll talk a little bit later in the class about doing things like Monte Carlo simulations, etc., which are slightly just more advanced. So instead of saying the probability is 0.3, I'll give myself a distribution, right, and I'll sample that distribution, so a little bit more statistics come into it, but roughly this is the principle, right, decision tree, decision analysis based on this principle. There are far more complex ways of doing things, right, so particularly when you're launching, say, space vehicles, right, there you have to be a little bit more careful about the kind of numbers you throw out, right, because these are heavy investments, but roughly this is the idea. This is decisioneering. So let's put it this way, you and I are going to play a game, we're going to toss a coin, heads, I'll give you 1 crore, tails, you've got to give me 1 crore, will you play the game? Okay, heads, I'll give you 1 crore, tails, you've got to give me 99 lakhs, will you play the game? If it's a heads, you get 100 crores, if it's you get 1 crore, if it's tail, you give me 99 lakhs. How many of you will play that game? Honestly, right? How many of you, if that was a real world proposition? 1 person, right? So what does that mean? Probability wise, right, you should play that game, right? The chances of you, the expected value is higher, you win more than you lose with equal probability, right? And technically if I told you could play this game 100 times, you might think a little bit differently, right, because there's equal chances to win or not. No, but you only get 1 shot at this game, right, it's a 1-shot game, okay. So this is in some ways the difference between a risk prone person and a risk averse person, right. So a risk prone person might say, I'll take the chance, right, a risk averse person might say, look, the downside of losing is actually much more than the upside of winning, right. So this is a profile question, so that's what a risk averse person does, right. So maybe you can't understand why people don't like 1.08, but looks like everyone in the class, right, falls within the risk averse category and is probably looking at 1.08 and saying it's not worth doing this project, okay. So that's one approach, right, but there's the other approach that says, come on, look, you can't take all of this fuzziness in the world and put it into numbers, right, and assume that those numbers have a sanctity and that you can take decisions based on them, right. I mean, on what basis are you saying the probability is 30%, right, and not 25%? What if it was 50%, right? How do you really know the future, right? So the managerial approach says, don't do it quantitatively, let's do it qualitatively, right? And this is sort of, again, Swapnika presented this slide. So you take a project, you take the risks, right? You figure out what to do with them. Maybe first you try to allocate or mitigate risks. What does that mean? The basic principle of risk management that you'll hear everywhere is allocate risk to the person who's best able to bear that risk, right? That's the most oft quoted statement. What does that mean, right? Essentially that means I am Chennai Metro Rail, I want to build underground tunnels, okay? There is a risk of the tunnels collapsing, okay? What do I do with that risk, right? And the answer is, let me figure out the most qualified contractor, right? And give that risk to that person, because that person is the best qualified person to manage that risk. So this perhaps is a person who's built railway tunnels all over the world. Okay, so essentially I've allocated risks to a person who understands those risks much better. That person hopefully has the experience of being able to tell me exactly where to do my soil do my soil boring. He probably, or he or she understands how I analyze the soil profiles and can figure out where does the soil need to be stabilized, where can I just run my tunnel bore. So they probably understand how to deal with that risk, right. So the first thing you do is you try to figure out how do I allocate these risks, okay. Another risk could be that, I borrow money in dollars from the World Bank, okay, but I am earning money in rupees here, right. So this power plant is set up by borrowing money from the World Bank in dollars, but the power is being sold to Indian citizens who are paying me in rupees. Now I have to repay the World Bank, okay, but if I have to repay the World Bank to that dollar amount, what happens if the rupee falls, right. So today, I don't know, what are we at, 72 odd, right. So 72, which means, yeah, so 72, so if I had to repay the World Bank a dollar, I would have to repay 72 rupees, right. But tomorrow if it becomes 75 rupees, right, then the World Bank is saying just give me my dollar, right, but I have to now get 75 rupees from people. I've got to go and ask them for 2.5 extra rupees, and they're going to ask me, look, why do I need to give you extra money for the same service, right. So there's an exchange rate risk, okay. Now how do I bear this risk, okay. So maybe the government bears this risk, right, or the World Bank bears this risk, and we say, although you've given me a dollar, right, we are going to count it as 72 rupees and I'm going to repay you 72 rupees, right, because you're lending in many markets, in some markets currencies will go down, some markets currencies will go up, net you will be, compensated. So let's just do lending in the local currency, right. So all of those are risk allocation, right, or risk mitigation. Okay, again, if you go back to the Chennai metro example of the tunnels are collapsing, maybe a risk mitigation technique is drill more boreholes, right. Don't drill a bore well every 100 meters because then you don't know what's there in between. Dig one every 25 meters, then you get better soil profile and you have fewer chances that you hit some rock that your tunnel boring machine is going through, etc., right. So that's direct allocation and mitigation, okay. So you do as much of that as possible, but then there are still some risks available, right. So and this is also, I think these two are both direct allocation, mitigation, shifting of risks, right, to all of that. But then at some point when you run out of ideas and there are still residual risks, okay, what do you do? Okay, so everyone, you've tried to sort of hedge your financial risks, etc., but those risks are not going away. Yes, you were able to hedge the World Bank's loan, but your coal supply for your power plant is coming from Indonesia. And Indonesia is telling you the same thing. They're saying pay me in, I don't know, ringgit or whatever they use in, or is that Malaysian? I have no idea. Currency that they use there. Okay. So you can't hedge all of your risks. Okay. So what do you do then? So then perhaps you try to diversify. Okay. So you have a portfolio of projects with the understanding, okay, for instance, demand risk. How do you hedge demand risk? Like economy might go bad, traffic on your road might fall. So, in Tamil Nadu, right. So what do? Perhaps you can have roads in 5 different states in India. Okay, and you could do it in such a way that some of those diversify your portfolio with the understanding that if something happens economically, if something happens politically, one project might suffer, but consequently there's an equal probability that another project might do well, right, and therefore you actually don't put all your eggs in one basket, right. So that's this strategy. This is the typical mutual fund investment strategy, right. I can invest in stocks and take a risk, or I can invest in mutual funds. The idea is if I have 10 funds in my basket, probably 2 or 3 are going to do poorly, but 2 or 3 will compensate, right. I diversify. And then finally, and of course I can also try to influence and transform. So can I come up with, if some of these issues are legal, right, can I come up with the ways in which I can, I can change the legal environment. So for instance, if the number of people on the road reduces, okay, let's say I want to now come up with a scenario where I want to increase the toll, right. So net, right, my overall revenue remains the same. Now, whether that's right or wrong is a different question, but let's say this is what I want to do, right. Can I influence the contract? Can I influence the law to allow me to put in a clause that says if traffic dips, I will do something else, right. So can I start influencing the project to create more safeguards against my risks, okay. If none of this works, then you've got to take some risk, right. At the end of the day, when you walk out of this class and you walk back to the hostel, right, there is that risk that you're going to get, or bike back to the hostel, you're going to get run over by the institute bus, right. So at some level, right, so you can diversify, right. So if you are bicycling with somebody, then you can find the best, safest biker, so you can allocate the, the bicycling risk to that person. You can maybe diversify by trying to take different routes each time, so you minimize the probability of getting it. But at some point, there's always some residual risk that you have to embrace. Okay. So the managerial approach says forget probability, do it qualitatively, negotiate, right? Figure out who can take which risk, right? Maybe even price it, okay? Figure out if you can influence institutions to reduce those risks, and if none of that works, whatever, you embrace risks, right? So these are the risk management philosophies, right? So that's fine, we'll get into risk management later, but what we want to talk about now are specific risks that projects face, and with the first set of risks we're going to talk about are the technical risks, the construction risks, right? So we'll take two cases, Montreal Olympics, which is an international case, relatively old, the project from hell, which is an Indian case, relatively new, right? So we'll sort of look at international, Indian, old, new, etc., right? So it depends on who you are within the company, right? So obviously top management is trying to look at also a diversification strategy, but any individual project you will enter only if you feel that that project has a chance of succeeding, right? So you do make decisions on an individual project level, right? But in a company, so for instance, let me give you an example of oil exploration. Here's an area where you think there are some dividends to be paid by exploring for oil, right? So you have a couple of projects in that area, but who knows, right? Maybe you'll run out of oil very quickly in that area. So I want to make a decision on that project based on some data and some understanding and some contracts, etc. is why I would go there, because I feel there's a chance that that project will be successful, right? That's what the project manager does. Now if the CEO has a fixed budget, right, and they want to sort of invest in projects, I would probably foolish for investing 3 projects in the same area, right? I might want to invest for one project probably in the Baltics or in the North Sea where there's some oil there, one project in some other area. So I will diversify where I invest from that perspective, right? But even if I go to the North Sea, right, I'm going to make sure that I do a risk assessment before I get into that project. So you do it at both levels. So there's no composite, right? But companies will do a bit of both, okay? Also it depends on the kind of company, right? So banks, for instance, tend to do a lot more mathematical calculation. Project sponsors, not as much, right? So project developers tend to be more gut feel oriented, more managerial in their risk approach, right? It's also in some ways a bit personality driven, right? So today there's a lot of sanctity given to numbers, right? Big data, machine learning, etc. Numbers can tell us quite a bit, okay? So we seem to be going a little bit more towards the decisioneering side. Traditional people in projects will say, look, all kinds of earthquakes can happen, typhoons can happen, you can't really predict any of this. It really has to be more managerial, right? So we look at our case studies and we can decide which approach would be better, okay?